Hello and welcome to another episode of Odds and Ends. In this episode, we'll be talking about a paper by Dr. Charles C. Block and Dr. Kathleen R. Retzma at Iowa State University and the USDA. Powdery mildew is one of the most damaging and widespread diseases of cucumber family members, with two species, Goloomyces cicomorum and Podospora, being the predominant species that cause this disease, the latter being more common, with 79% of all strains being derived from this species. Disease resistance has been introduced through R genes, obtained from different cultivated and wild specimens. The first two used R gene sources were the cultivar Chinese long, through one of the cultivars called Puerto Rico 37. The other lineage from which R genes are derived is PI 197087, through the cultivar SC50. The ambition of this paper is to identify all the different cultivars that have potential disease resistance within the USDA collection, and find out which ones have R genes, which ones are intermediary resistant, and which ones are susceptible. To that end, 977 cultivars and other accessions were analyzed in the cucumber germplasm collection. The plants were inoculated and allowed to develop the symptoms, and how far the disease spread determined how resistant the cultivar is. Resistant cultivars were identified as being clean, having no mildew whatsoever. Moderately resistant had small amounts or slow-growing colonies of mildew, and susceptible ones get run roughshod over, being wholly infected. The data was then collected and analyzed using the PCSAS software, and all the data obtained from that will be compared using a statistical test called the Waller-Duncan Least Significant Difference Test. And here are the results. Of the cultivars, 94 out of the 977 cultivars had a mixture of intermediate, resistant, and susceptible cultivars. These are likely open pollinated lines that have greater genetic diversity. 41 out of the 977 contained only plants with an intermediate or resistant reaction, probably inbred lines of some sort or another. And the remaining 54 were highly heterogeneous, meaning that all plants in some combination were a mixture of susceptible, intermediate, and resistant, to a far greater extent than the previous populations and accessions. And it makes sense, most of the germplasm within this large-scale collection is a mixture of open pollinated lines, which are subsamples of land races which are a very genetically diverse population. There was, however, an absence of resistance in some of the larger germplasm groups, such as those from Turkey, Yugoslavia, Iran, and Spain. Among Middle Eastern countries, only 4 resistant genotypes were found within these 977 cultivars. Within the realm of Europe, there's 94 cultivars of either intermediate or resistant traits. Cultivars from China, India, and Japan were highly represented when it comes to resistant varieties, with 41, 13, and 11 resistant accessions, respectively. There are, however, 8 cultivars that are highly resistant without being Asian cultivars. These include Numerous and Wilto from the Netherlands, Kazepi Livmi from Hungary, Parad 176 from Ukraine, Concord and Parad from Russia, and Leo No. 1 from Hawaii, as well as Cool and Crisp from Kenya. None of these cultivars are traditional land races or open pollinated lines, however. Rather, these cultivars were made in modern times through modern breeding. Several R genes have already been discovered within several of these varieties, such as Lehal No. 1, SC50, Spartan Salad, and Marketmore 76. Most of these R genes are derived from India and Japan. A sample of a Japanese landrace called PI212233 became a source of resistance to powdery mildew in the cultivar Spartan Salad, which was then used to make Marketmore 76. There was a total of 20 accessions with R genes within them. The 2 exceptions are the Hungarian and Kenyan varieties. There's also 30 landraces / open pollinated lines of Chinese cucumber within this collection. These populations consisted of mixtures of susceptible, intermediate, and resistant individuals. Based on this information, These less developed lines seem to contain unique strains of different disease-resistant genes, both in a quantitative disease resistance sense and in the R gene sense. Most of this resistance seems to be derived from original Asian populations, and it's likely that we can use these less developed varieties from Asia to breed new cultivars with rare disease resistance. And that about covers everything. Thank you for watching. Thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.